Okay, so compound interest. If we remember, compound interest is paid on the value in there at the time, and it will change when the value changes. Formula that we need for compound interest sometimes in the textbook is shown as in this form with A equals PRN. I don't necessarily like this form, and I'll show you the way I'd like you to write it later on, but it can be shown this way. If it is shown this way, A is our value at time N, so our end value after 1 year or 2 years or 3 years. P is our principal, N is our number of time periods. But to find R, we have to do this 1 plus R over 100, where R is your interest rate per time period. Instead of doing all that stuff, I like putting it together in one formula and just having this formula from the start and making sure we work with this. Our formula for compound interest being A equals P, 1 plus R over 100 to the power of N, where R is my interest rate per time period, N is my number of time periods, P is my principal, and A is my value at the end. So all we're going to do is do two examples. First example, and I would always highlight or underline or do something for the things that are important. You got $5,000 is invested into a savings account paying 2% per annum, compounded annually. For compound interest, this how often it's compounded becomes a really important aspect. What is its value after 4 years? So we know it's a compound interest problem. So the first thing I would do for compound interest is write my letters down the side of the page. The things that I know or want to know is we've got an end value, we've got a principal, we've got an interest rate per time period, and we've got a number of compound periods. Do we know the end value? We don't know the end value yet, so there's a question mark, sort of a question mark, a bit hard with this software. P, principal, $5,000 is the amount we borrowed, so my principal is $5,000. My interest rate is 2% per annum, so 2% per year. I'm going to write the PA here because the per annum or per year becomes really important when we move on to our next example. What is our value after 4 years? It's compounded annually, so it's 4 and it's compounded annually, so this is annually as well. This annually, that annually matches up, so we're right to go with these numbers. Now, write your formula out. Your formula from on the last page, A equals P, 1 plus R over 100 to the power of N. Plug in the values we know. Your principal was 5,000. 1 plus your interest rate was 2 over 100 to the power of 4. Put all that into a calculator, you'll come up with an answer. Your answer will be 5412.16 when you round off to 2 decimal places. Again, always ask yourself, do these answers make sense? We've invested $5,000, we've earned interest, so it should be a bit more. $5,412 is a bit more, so we've made money. This answer seems to make sense for what we've done. This answers our first question where it says, what is its value after 4 years? Sometimes a question will ask us for value, sometimes it will ask us for how much interest has been made. If we look back down here and we want to know how much interest we have been made or how much interest has been made, we know we started off with $5,000 and we know we ended up with $5,412.16. So we want to know how much more this is than this. So to find out how much more it is, $5,412.16, take away the $5,000 that we invested, tells us that we made $412.16 in interest. First question done. Second question looks very, very similar. We've still got $5,000. It's still invested in the savings account at 2% per annum. It's still there for 4 years, but our big difference now is it is compounded monthly. This is where this stuff gets a bit more difficult, and this is where people traditionally seem to make mistakes. I'm still going to write the same letters down because I'm still using the same formula. I've still got A, P, R, and N. The end value in this particular case is still what I'm trying to find, its value after 4 years, so it's still a question mark. Principal, how much we put into the investment, is still our $5,000. Interest rate for now is 2% per annum, but the problem is it's compounded monthly. So instead of being 2, we're not going to use 2, it's 2, but it's shared between the 12 months that it's compounded. So we use 2 over 12. You could find this as a decimal and use a decimal. I personally like using the fraction because it just eliminates any rounding errors that could happen. My number of compound periods, it's compounded for 4 years, but it's still compounded monthly. So it's compounded 12 times in that year. So therefore it's 4 times 12, and this one is just as easy to put in the number of 48. Again, you could just leave it as 4 times 12 and put 4 times 12 into your formula. Now, again, we go back to our formula. Always write your formula out first. A equals P times 1 plus R over 100 to the power of N. Writing your numbers in. 5,000 times 1 plus, my interest rate is 2 over 12. So on a calculator, I'm going to set up a fraction. On top of that fraction, I'm going to do another fraction with 2 over 12. You could simplify this to 1 over 6 if you know what it is, but 2 over 12 is fine. Over 100 to the power of N, which was 48. I'm going to swap to a CAS calculator in a moment to show you how to put that in if you're not 100% sure, and we'll come back with the answer in a second. Okay, so on the CAS calculator, I've got A out by itself, so I just need to put the equation in. It was 5,000, open up the set of brackets, 1 plus, now I need a fraction set up, so your best bet for a fraction over here. That thing gives you a fraction. I want 2 over 12 on the top of my fraction, so if you're up in this box, which you are, you can set another fraction up in there. You can then do 2 over 12, which was over 100. You need that to the power of 48. Press enter. On this calculator, my setting's set up for exact, so it's giving me a long, complex answer. If I need to know the approximate answer, press Control, then your roughly equals, and it gives us $5,416.07. $5,416.07. So in summary, when you're working with compound interest, make sure you look for how often it's compounded. Your interest rate must be divided by your number of compound periods in that year, and your time must be times by the number of compound periods in that year. If you struggle to remember a couple of things, this might be well worth writing down somewhere. There is 12 months in a year, there's 52 weeks in a year, 365 days in a year. We don't use leap years unless we're specifically asked for, and there's 26 fortnights in a year. Because there is 2 fortnights in a week, don't make the mistake of saying 12 months, 2 fortnights in a month, and 24, because there is actually 26 fortnights within a year. Again, just remember your interest rate is your rate divided by however many times it is compounded, and your number of compound periods is your number of years times by however many times it is compounded.